For anybody watching this video right now, this is the Unit 7 quiz. Kind of goes over the first 4 sections of this geometry document. Here we go. So the first one says, which is a secant? Secant by definition is a line that goes through one side of a circle out the other side of the circle. So in this picture right over here, ST is the only one that we can reference as a secant. So one would be D. Number 2, which is a chord of the circle. There's 2 different chords that are on here, chord QR and chord ST, both of those being segments. However, the reason why this one doesn't work, it's not super easy to tell, but there is like little arrowheads on the end of those ones, and the chord is just a segment, so both points lie on the end of it, so that's why that's QR. 3, which is not a radius of a circle, so not a radius of a circle, so QR, that goes from the center to an edge. QP, that goes from the center, or QR does not, I'm looking at the wrong letter. So QR, I don't even have to go any further. QR is not a radius. PS and PT definitely are, they go from the center to the edges. Which is a tangent of the circle. In this case, tangent means a line that touches at one and only one point. So that would be this one on the outside, right there, and we could call that line UV, which would be C. So DAAC through there. On this one here, it says find the length of each radius, identify the point of tangency, and write the equation of the tangent line at this point. So the radius of circle C is this one right here. So it's 1, 2, 3 boxes. Radius equals 3. Radius of D is 1, 2 boxes. So radius equals 2. Point of tangency is the place that both the circles touch. That one's right there, and if you count over, it's 1, 2, 3 to the right and 2 up, so that's 3, 2. And tangent line is the line that goes through both those points. So it's a vertical line right there, and all vertical lines are where x is constant. So that's an x equals 3 for the equation of the tangent line. Everybody okay in here with those ones? And what those is? Okay. Down here it says FE and FG are tangent to circle J. Well, if that's true, then this segment and this segment are both congruent, and therefore we can write their expressions equal to each other. I'm going to go ahead and distribute this to when I write this down. So that's 6 plus 12x equals 14x minus 8. I move the 12 over, minus 12x, minus 12x. I move the 8 over, plus 8, and I get 2x equals 14, and therefore when I divide by 2, I get an x is equal to 7. Now, of course, it doesn't ask for x right here, but it does say, what is FG? Well, FG is that segment, so that means I need to plug my 7 into here. And 7 times 14, that's 98 minus 8. Looks like FG is 90. Can I get agreement on that? Anybody else get a 90 out there? Okay. It says name the theorem that you use, and again, we've talked about in this class. I don't need to be specific on it. Just the fact that you know that anytime that we have a circle and I draw in 2 tangent lines, that point of intersection creates 2 congruent segments. Okay, on this one right here, it says find the measure of each one of these things. We know that those little boxes were just font issues. So this is measure of arc QS and measure of arc RQT. Well, before I even try and find those answers, I'm going to go all the way to here, and I'm going to say, let's just find the stuff that I'm missing on this one. So I'm hoping I see this, that this is 47 and this is, is that a 55? So together these 2 things are 102, and if those 2 things are 102, then this one right here must be a 78, because that goes exactly halfway across the circle. So it has to add up to 180 altogether. If this is 47, then the one next to it, because it forms a straight line too, must be 133. And if this is 78 and this is 55, I could do it that way, or I could go, if this is 133, then I know this one right here has to be 47. 47 because that adds up to 180, or 47 because these two angles are, what do we call those things? Two angles that are directly across from each other? Vertical angles. Are we good with that? That's that VAT theorem from before. So now I'm going to go back here. I'm going to ask, well, what the heck is QS? QS is from here to here. So that's a 47 and a 78. I think if I did my math right in my head, that's 125. Can I get a 125 out there? Anybody got that? Yep, 125. And this one says R to Q to T. So R to Q to T, that's from here all the way to here. So I'm going to add up a 47 and a 47 and a 133. I got a 227. Anybody else got a 227? 227 it is. At least I'll trust you. So 227 degrees for that. Good on how to set that up? Makes sense. Sweet. These ones down here, these are a little bit more complicated on some of this stuff. So it says first on this that AC is 47.2. So that means the distance from here to here is 47.2. Because that segment or that chord that's going across there is perpendicular to a radius. One of the theorems we said that those two parts are equal. So I could go ahead and go on, and I do 47.2 divided by 2, and I get each one of those things right here to be 23.6. 23.6. And that helps me, but I'm trying to find PL, which is this thing right here. Well, this has a radius of 28, and that has a radius of 28. So if that's the case, then on this triangle right over here, I've got a 28 for this side, and I got a 23.6 for that side. And I can do Pythagorean theorem to find this last thing. Let me kind of blow that triangle up for you here. So it's this one here, where this was 28 and this was 23.6. I could find this segment, we'll call it X, and then I'm looking for this thing up here, which was Y. That's P to L. So I'm going to find this, and then take that away from 28 because that's also a radius. So on the calculator, hopefully we can do this. 28 squared minus 23.6 squared, enter, raised to the 0.5 power. I get 15.06 for my X. So 28 minus that last answer should get 12.93 for PL. 12.93. Now, with that being said, you could have also known that those two angles right there are congruent. Taken the 65 away from 180 and got 115 and split that in half and used SOHCAHTOA with those two angles, which I think some people did in the class too. Same number though, 12.93. Sweet, awesome. Any questions so far on page 1? Does that feel okay? Fire up. Okay. Page 2, back side. The first thing this one says is find the area of sector LQM. Area of sector LQM. Well, that's this region right here. So we know that the area of a sector is central angle, right, that forms it, over 360 times pi times radius, which in this case was 6, squared. So all I'm going to do is put that directly into my calculator. Likewise, arc length of NP, that's this. Well, since it's vertical angles with the one across from it, that's also 75 degrees. So 75 over 360, right, times, but this is an arc length, not an area, so I need to multiply it by the circumference, 2 times pi times 6. Both of those formulas should go in pretty easily on the calculator. I'll go ahead and do this one first. So 75 divided by 360 times pi times 6 squared. I'll put it in all at once, just like that. Oof. And I get 23.56. 23.56. And was there any units? Inches. So square inches, or inches squared. The other one, just for some reasonable sense sake, this length right here was 6. If I wrap it around, it looks like this length should be pretty close to 6. So if I get a number that's not around 6, right, I think it might be a little bit longer than that. But if I didn't get a number when I do my calculations close to that, I'd be like, that doesn't make any sense, right? I got to check that all the time. So here we go, 75 divided by 360 times 2 times pi times 6, my radius, 2 pi r, and I got 7.85. And that number makes sense based on what we just said. If this length right here is 6, that probably goes to about right there. I've got a little bit more left over. That's what the number shows. It's a little bit more than 6. Everybody okay on those two? Awesome. Here we go. On this one, it says find the measures, also explain why it works. Well, there are really two things that we're looking at right now, and I'm going to kind of draw them separately here. So for A, little a, that's this thing right here. So I'm going to draw this picture, and that gives me this angle like this. And if this is a diameter, that means that that arc is how far? How far is this arc? The measure, not the length, but the measure of that arc if this is a diameter. 180? Everybody agree 180? Awesome. So if that's 180, then this angle right here has to be half, so that's got to be a 90-degree angle. And then right over here, it says that that angle is equal to 3 times 14a minus 12. So I'm going to go ahead and distribute that in. 3 times 14a is 42a. Minus 3 times 12 is 36, equals 90. That's the expression right over there. I just did the distributive property. Put that in. Subtract remove the 36 to the other side, and I get 42a equals 126. And I divide that, and I believe my a is 3. Can I get a yes for that? Do you have a lot of freshmen missing too?
Yeah, I need to go.
Oh.
I have 2 freshmen actually missing. When you get a moment,
Oh.
come see me. Just,
Okay. You're on video now. You just asked that question.
Good.
Sweet. 3. Why does it work? Because an inscribed angle is always half the arc that it intercepts. Inscribed angle is always half the arc that it intercepts. Now, when I do this other one, I'm hoping this is even easier. It says that this right here is 50 degrees, and it wants to know how big that angle is, right? Do you see how when I separate that, it's not as cloudy, it's not as messy? Is that good? Yeah? You with me good, Megan? It almost looked like you were texting on your phone. Now that's on video too. 25 degrees. Everybody get 25 degrees? One more time. Why? Because an inscribed angle is always half the arc that it intercepts, right? Not a central angle, right? Central angle is the one in here. How big is the red angle? 50 degrees, the same as the arc that it intercepts. That's the difference between those two things. So red is 50, blue is 25. Okay. This says find the area of the segment GHJ to the nearest hundredths. GHJ. But it says area of the segment. That was the thing that we said yesterday was that thing right there, right? That little section. So we said we could do area sector, right? Area of the sector. Area of the sector minus the area of the triangle. That was our formula for it, yes? So I'm going to do the area of the sector, 90 over 360. Now, would you guys be okay if I just used 1/4 for that? 90 over 360, same as 1/4? We could use that if we wanted. Times pi times 14 squared minus 90 over 360, right? times 2 times pi times 14. And I literally can just put this entire thing into my calculator at one time. I'll go ahead and show it to you right here on the calculator. So clear. I'm still going to use the 90 over 360, but again, you could use 1/4 if you didn't want to do it. You honestly could use 0.25. It's the same thing. 90 over 360 pi 14 squared. Now, if you have a calculator that's not one of these, you might have to do it all slow at one time, and then get like this answer, and then get the other answer, and then subtract them. If you have one of these, you can do it all at one time. 90 divided by 360 times 2 pi 14. And I think this calculator will just process it. If not, you'd have to do some multiplication in between them. This gives me 131.95. Show me hands. How many people actually had 131.95 before we started? Ooh, nobody. Did you get that on your calculator right now, though? Yeah? Are you all in agreement in this classroom that 131.95 is right? Okay. So there we go, 131.95. And then I got to look. It's got a little m right there. Got a little m right there. So that's meters squared. Meters squared. Come down here on this one. It says find the angle measures of ABCD. That was something we did right at the end of class yesterday. We said that anytime that you had a circle and you connected 4 points on the circle like that, and it's called inscribing a quadrilateral, that the angles that are opposite of each other are supplementary. So all we have to do is we have to write those equations. Supplementary. So I'm going to go ahead and do this. So I'm going to go this way. So I got a 4y plus 13 equals 5y plus 5. That's one equation. And then I'll do the other one. I got a 15x plus 35 equals 25x minus 15. So again, just make sure you do the distributive property to both of them. I'll go ahead and solve the blue one first. I subtract the 4y and I get y. I subtract the 5 and I get 8. Again, that's not either one of my answers, but it does tell me what y equals. And if y is 8, I'll go ahead and put it up into here. 4 times 8 is 32, plus 13 is 45. So angle B is 45, and angle D across from it must be 135. Double checking my math. Yeah, not really well drawn to scale, but that's the expressions they use, so that's what our answers are. Everybody get 45, 135? You got 45 for D? Yeah. Oh. This rewind. I said it, and then I was thinking about what Mr. Walters just asked about. I'm like, I wonder what it was. That's bad. This is just dumb. Don't do that. I literally said it was supplementary. Those are not equal to each other. They are not. But that's good. That's why we did it, right? Because that didn't make any sense. Okay, but 3 of you nodded, so thank you, Nathan, for pointing that out. We said that 4y plus 13 plus 5y plus 5 should equal 180, right? Because they're supplementary.
I just put the 2y equations equal to each other and it worked out.
But they're not equal. That's my point. That it should, because that'd be bad. That doesn't make any sense. Now, they are supplementary, so we're going to try it again with that equation, and that gives me 9y plus 18 equals 180. 9y equals 162, and y equals, let's do a little math here, 162 divided by 9, is that 18? It is 18. 18. Awesome. Now let's see if this makes more sense. Now I plug it into here, and I got 4 times an 18 plus 13. 4 times 18 plus 13. I got an 85 degree angle for angle B. That looks so much better than on my picture. And then I got a 5 times 19, 5 times 19. That's 95, which of course it is because those had to be supplementary. So I got an 85 and a 95. Does that make so much more sense? Sweet. Almost like I planned on missing that one on purpose just so we could talk about it. No, that wasn't the case. Just going too fast. So let's try this again over here. 15x plus 35 plus 25x minus 15 equals 180. 40x plus 20 equals 180. Subtract the 20 and 40x equals 160, and x equals 4. Everybody follow on getting a 4 for that now. Sweet, so I plug it in. 4 times 25 is 100. 100 minus 15 is 85. Good deal. This is not necessarily the case that you're going to have two sets of identical angles. That is not. You hear me? Not. Okay. Over here on this one, I plug it in, and 3 times 4 is 12, plus 7 is 19, times 5 is 95. Oop. 95. 85, 85, 95. So far, so good. Let's go to this one here. It says the gear of a grandfather clock has a radius of 3 inches. To the nearest tenth of an inch, what distance does the gear cover when it rotates through an angle of 88 degrees? Now, it might just all of a sudden freak you out because it's got a whole bunch of words, but I'm just going to try and draw a picture. So basically, I got this thing. Now it's got little gears on it. That means there's little things that stick out that help grip with other stuff. You know, kind of thinking of like a, if you don't know what a gear looks like, think of like a saw blade, a circular saw blade. But it says it's got a radius of 3 inches, right? 3 inches. And it says it's going through a rotation of 88 degrees. Well, and it wants to know how far that traveled. Well, it's just an arc length. So we're doing 88 over 360 times 2 times pi times the radius of 3. Does that follow okay on that? That's what those words meant? And then I'm going to put that into my calculator on 88 divided by 360 times 2 times pi times 3. And I got 4.607 inches. 4.607 inches. That's how far it goes. Move over to this one here. It says circle A has radius 9, circle B has radius 4, and CD is a common tangent. Find the length of CD. Well, that's that length right there. And I believe we've done this, maybe this exact same problem. It might have been a picture from what we used before. But we're going to drop this segment straight across, make it parallel to that, so that's a right angle. If this radius is 9 and this radius is 4, then that's a combination of those two radiuses that are pointed right at each other. So that length is 13. Again, if this is 4 and this is 9, then this length over here has to be 5. And CD is the same thing as this horizontal length right here. So I'm just going to do the Pythagorean theorem, and that says 5 squared plus x squared equals 13 squared. Knowing that these two things are the legs of that one. So on my calculator, 13 squared minus 5 squared, 144. The square root of 144 should be 12. And I get a length of 12. So that's what CD is. Good deal. This challenge one says, what's the area of the trapezoid that is not part of the circles? Have you guys tried that at all yet? Because that's a little challenging one. So what I'm going to do is I'm going to leave that one because I don't want the people at home necessarily to know it. But really, maybe draw this picture out bigger on a bigger sheet of paper and really think about anything that you know. I will say this is what I'm looking for. I'm looking for the area of this section right in there. Looking for the area of that section right in there. It's irregular, so we're going to have to do some subtraction from some things that we know. Okay? Hopefully that was helpful, and we'll see you later.